Why do people go bald?
Why are baboons' bums red?
What's a light year? Why do leaves go brown in the autumn? Why do monkeys like bananas? Why do some things glow in the dark? Why do animals not understand you? Why do my receipts fade after a year?
Don't know the answer? Ask the Naked Scientists.
Hello and welcome to this week's Ask the Naked Scientists with me, Sue Marchant, and Dave Ansell. Now, there's one question that's come in here on the text from Trucker Gaz. Doctor, I'm sorry, but this may be something I should know, but I don't. What is a light year? How long is it? And at what speed would I have to travel to complete one in one of our calendar years? Good question.
It is a good question. Hint is in the name. A light year is how far light would travel in a year. Now, light travels at about 300,000 kilometres every second, so it's quite speedy. And so if you multiply that by all the seconds in a year, you get about 10 million kilometres, give or take. So a light year is about 10 million kilometres, and you'd have to be travelling at the speed of light, which, if you have any mass, is in fact impossible, because Einstein's theory of relativity says that the speed of light is the maximum possible speed you can travel at. But if you want to travel, you'd have to be travelling at the speed of light, and you'd have to travel for a year, so 300,000 kilometres a second for a year, and you'd travel a light year. Astronomers use them just because the astronomical distances are so immense that measuring them in kilometres would just be silly. The number of zero, you'd run out of paper on the page. So they use a much bigger unit called a light year, which is a bit easier to get your head around when you're dealing with thousands of them.
Could we have that in miles as well?
Very quick calculation, about 6 million miles-ish.
Ish.
5 or 6, somewhere around there.
Right. Is anybody any the wiser? I hope so. So a light year then is much longer than our normal year.
It's used for a year is a measure of time. Light year is a measure of distance. So it's a very large measure of distance. Yes.
Fine, Gaz. I hope that's helped you out. What else have we got here? Hiya. Could Dr. Chris tell me anything about the time's arrow theory? Do you know about that?
Oh, this is, I think, probably the arrow of time, because according to, as far as we know, according to the law of physics, there's nothing special about one direction of time. Because if you reverse time, then all the laws of physics still work, and there's no particular reason why we should experience time travelling in one direction. And it's actually quite a deep philosophical problem with physics, which we're not entirely sure about. The only thing that people are looking into this, and one idea of the reason why time travels in one direction and the other, is just that when the Big Bang happened, everything was you got all of the matter in a very, very small space, and it's kind of very ordered. And if you have something, if you imagine your house, if it's very, very tidy, over time things get more disordered. Mine certainly does, and it gets messier, and it's basically, this is called entropy. All the energy in the universe tends to get spread out more and more, and gets more and more messy and more evenly spread over everything. I know everything in my house gets spread everywhere unless I try very, very hard. And so the idea is that just because at the Big Bang all of the energy and matter was all in one place, and then over time it's slowly getting messier, and the only reason why time is travelling that direction is just it happens that everything was all in one place. If everything had gone gone all over the place and all into one place and then out again, possibly before everything was all in one place, maybe time would feel like time was going the other direction. It's very hard to tell.
It's a bit like me picking my handbag up then and dropping all the stuff out of it.
Yes, just because you started off with everything in your handbag and then it sort of gets distributed around the house.
Around the studios tonight, yeah. That's
the only way that's the only reason why we think that time is travelling in one direction, not the other.
You're listening to Ask the Naked Scientists with me, Sue Marchant, and Dr. Dave here live in the studio. We have a caller. So let's go to Stephen on the phones. Hello, Stephen. You're through to Dr. Dave. Hiya.
Hi. I had an email the other day out of the blue about this. You can change things on your car, make it run on gas or water, and in view of all this fuel prices, people nicking things out of people's petrol in farms, I was just wondering if these things that you can fit onto, alter your car to run on gas or water, if they're credible at all. That's what I wanted to find out.
I think the two are quite separate. Running on gas, as in gas you get out of your heating system or to town gas or whatever, natural gas is entirely possible. They used to do similar things during the Second World War. I don't know if you've seen Dad's Army with the big balloons on top of trucks.
Vaguely.
They'd attach a big sort of balloon on top of a car and fill it up with gas. And then you can burn gas, so you can run a car engine on gas. It's absolutely fine. It's not entirely practical. It slows your car down a lot because the gas you can't squeeze the gas into a liquid, so you'd have to keep it ridiculous pressures if you're going to actually keep it in a gas cylinder or something.
Right.
But you can certainly run a car on natural gas. I think, in fact, some of the very early internal combustion engines were running on probably coal gas rather than natural gas, but gases. The other one is, can you run a car on water?
Fracturing water, I've heard it called.
Fracturing water. Again, this is one whereby it is possible if you split water, you'll get hydrogen and oxygen, and you've got to put a whole lot of energy in to split the water, and you get hydrogen and oxygen out. Now, hydrogen will burn in oxygen very, very well to form water again. However, the energy you get out will never be more than the energy you put in to split them. In fact, it's normally less because the splitting process is inefficient. So you can, if you split the water, if you plug your car into the mains and you split lots of water into hydrogen and oxygen and collected them, and then you could run the car on that, which is what a lot of big car companies and many other people are trying to do. When they're talking about the hydrogen economy, this is what they mean, splitting water and running cars on hydrogen. You can actually get things called fuel cells, which are a bit like a battery, which run on hydrogen, which are more efficient than a normal car engine. But I think a lot of these things, they're talking about putting some little thing inside your car which uses electricity from your alternator to split water and then putting that into the car engine and running your car on that. So there's no way you can get more energy out than you put in. So I would have thought that it would just make your car less efficient because you're going to lose energy because you've got to run your alternator hard. You've got lots of electric currents flowing all over the place, and splitting water isn't very efficient.
Would it be cheaper than the fuel prices we're having to pay now, though?
But you'd have to use more petrol in order to split the water. If you plugged it into and used electricity to split it, then you could possibly do that, but that's quite difficult, and storing enough hydrogen in your car to run is difficult.
This lavish video, email with a talking voice. Unfortunately, it didn't go through, but, and they're saying you can buy for about $150 something you can fit it. So you think it's all Heath Robinson then?
I think it's all either self-delusion, or it's probably self-delusion, or someone trying to get the $150. Yes, probably. I'm afraid.
So we're still a long way from being able to run a car on water, not have to worry about high fuel prices then?
I'm afraid so, yes. I mean, the problem is that water is sort of like the waste product of burning things. If you burn petrol, you produce water.
Right.
And so you're taking something with lots of energy like petrol and turning it into something with less energy like water. So water is a very low energy substance. So unless you put lots of energy into it, you're not going to be able to run cars on it.
OK, back to the drawing board, thank you.
Indeed. Good luck.
Stephen, thank you so much indeed. We can't win, can we? Take care.
No, bye.
Dave Keith would like to know if it is possible to have a module orbiting the Earth with a hook coming down from it which could pick up pods and modules or the like and deposit them elsewhere in the country. Ooh, transport solution.
It's an interesting transport solution. There are various ideas which work on this sort of principle, but mostly they've been designed in order to put things into space. I think they'd probably, if you had a satellite which was orbiting quite low down, then moving very, very fast, tens of thousands of miles an hour. And so if you had this grappling hook coming down through the atmosphere, there'd be lots of drag, and it would slow the satellite down. And you could, and then the satellite would slow down and lose height until it collided with the Earth. However, there are some other interesting ones it has been suggested that one thing you could do is if you attached a big spinning grappling hook onto a satellite, then you could sort of launch a rocket upwards. And so it could just about get somewhere near the edge of the atmosphere. Then the grappling hook could come down and catch the satellite and then kind of whisk it out and throw it outwards, maybe towards the moon or something. And that this would lose some energy from the satellite, but then the satellite could use a kind of much more efficient slow engine to slowly boost it up its orbit again until it could then catch another one and shoot another satellite out to the moon, which is much more efficient and uses much smaller rockets than the equivalent of just firing a rocket straight to the moon. There's a lovely thing called a space elevator, where the idea is you build if you go out to 36,000 miles above the surface of the Earth.
As you do.
Then, as you do. In fact, there's quite a lot of satellites out there. because the time it takes you to orbit is exactly the same time as a day. Basically, the idea is to take a piece of string from the Earth to just beyond 36,000 miles. This is called the geostationary orbit. And because this means the Earth is pulling the satellite round, this string is going to be in tension and going to be pulled. You can then build little crawlers to climb up this big, long string. 36,000 miles of string. It's not a minor exploit. And then you can basically just have little crawlers which slowly take things up into orbit, and you can move things up into space much more efficiently. None of this big rockets and lots of expensive things which can blow up. You just gently climb this long piece of string. The problem is that if you did it with steel, basically you've got a piece of string hanging 36,000 kilometres. Steel isn't strong enough. In order to be able to hang a 36,000 kilometre piece of steel downwards, the top of it would have to be like 1,000 miles wide in order to be able to support, to hold the bit just below, which is 900 miles wide.
So it's not going to happen then, Dave, is it? If
you can get very, very, very strong materials, they think it's just about possible with carbon nanotubes or possibly something called graphene, which is a special kind of graphite, very thin pieces of graphite. They're just about strong enough where it might be possible, in which case it would make getting up to space like 100 times cheaper. And maybe we actually might be able to get out to those planets and not just hang around on Earth all the time.
All right, OK. Dr. Dave is here answering your questions live on air. Ralph is on the telephone. Good evening, Ralph.
Good evening.
Now you're through to Dr. Dave. What's your question?
Well, the question is, I had time watch on TV 2 or 3 weeks ago.
Yeah.
And the Iceland volcano went up in 1850 to 1854.
Yeah.
Now, during that period, 2 or 3 days afterwards, it produced a obnoxious gas, which was a killer. It travelled all across Europe, round through into this, and then finally finished up in this country. And it killed quite a number of people. Now, what's the chances of another volcano doing the same sort of thing?
It's certainly possible. This is a huge volcano. It didn't just put out lots and lots of noxious gases. It also, I think it cooled the climate for at least a couple of years.
That's
really
right,
significantly, so several degrees centigrade, because it pushed so much sulfur dioxide particles up into the high atmosphere, which reflected the sun. It's certainly possible you do get very large volcanic eruptions relatively regularly. As in, I think, just from my reading of history, it's probably of the order of once every few hundred years at the very least. Probably getting on for 1,000. I mean, in Iceland, probably you'd have to wait several thousand for another one that big. But you do get very big volcanoes, and they do cause all sorts of havoc and change the world's climate for a few years. Mount Pinatubo going off in the Philippines, I think it was, cooled the Earth by a degree centigrade for a year or two by, again, pushing up so much dust into dust and sulfates into the stratosphere and the high atmosphere. I couldn't tell you how likely it is. I can tell you it's almost certain to happen again at some point. I think if it's a volcano which has done that sort of thing before, we'd probably get some warning of it, definitely a few months, if not years, because there are lots of volcanologists looking at these big volcanoes because of the havoc they can cause. But I'm afraid I can't give you any better answer than that.
Oh, thank you.
All right, Ralph.
That
yes?
previous article you done, where they were talking about gas...
Yes.
Marks and Sparks have actually got a lorry runs on one of these gas cylinders. Yeah,
you can. Sorry, I should have added that. Yeah, you can certainly power cars with liquid petroleum gas, LPG, the sort of stuff you run gas barbecues on, things like that.
That's right.
You can even fill cars up with it at some petrol stations.
Yeah.
It's a bit more. I think burns a bit cleaner than petrol and diesel, but unfortunately, water won't work.
Don't try it at home without a proper conversion.
No, what I was just going to say. Well, you can smell it. It has got a very nice scent to it.
Has it?
Yeah, I have smelt it before now.
Yeah.
Oh, okay.
I think there's a couple of buses that definitely used to run on it in Cambridge as well. And they smell of like gas cookers.
That'll be the next thing, won't it? Some bright spark will come up with, have your LPG perfumed. God. Ralph, thank you very much indeed.
Okay.
Take care.
Thanks very much.
Bye-bye.
Bye then.
All right, Daniel has sent us an email. He says, could you ask Dave if he can explain, and I must say this properly, chromatography?
Chromatography sort of means making pictures. Graph means pictures and chroma means colour. Making colour, sort of pictures from colours. If you get a sort of water-based pen and put it on some paper and put the paper in some water, Slowly the water will work its way up the paper due to capillary action. It will slowly work its way up the paper because it's attracted to the fibres in the paper, and it works its way up. As it does it kind of drags the colour from the ink upwards with it. Normally an ink is made by mixing different colours, and different colours will move at different speeds. So maybe say the red moves very quickly and the bluer colours will move slowly, and you sort of spread out the colours from your single ink. The reason why different colours move at different speeds, basically, if you imagine the little molecule, the little lump of ink, some of them stick quite well to the paper fibres, and some of them really like being in the water. And so the ones which like being in the water will spend all their time in the water, so move quickly. The ones which spent most of their time stuck to the paper fibres will just sort of hang around a lot of the time, and occasionally fall off and into the water and get moved up a bit. They'll stick to another fibre, and then they'll hang around for a while, and then move up a bit with the water, so they'll move much more slowly. Chromatography, you can make pretty things. You used to be able to do it with Smarties, but they've changed the ink colours on Smarties, but you can definitely do it with felt pens. And you can make pretty colours, but it's actually really important in chemistry, because if you've done a whole lot of chemistry and you end up with a whole mixture of all sorts of rubbish, and you want to find out what's in that mixture, what you do is you put it through a column, which is the same idea. You put a whole mixture of different things into the column, and they'll slowly move up through this column at different speeds. You pump solvent along it, and some of them will stick to the crystals inside the column more than others. And so some things will move up quickly, some things will move up slowly. So you then measure what's coming out of the column over time, and you'll get one molecule coming out, then another one, then another one. And it's very important for doing analysis on what's in a mixture of substances, because a lot of the things to find out what a substance is don't really work with mixtures, so it splits up mixtures into lots of different things.
Okay. Right, well, there's a little email that's come in here. Nigella says, is it possible to have a stealth car?
Depends what exactly you mean by stealth. I mean, at the moment, you could certainly build a car which wasn't picked up by radar, which is what they mean by stealth aircraft.
Oh, yes, yeah.
And the idea of stealth aircraft is that they have lots of paints on them so that they absorb lots of radar, they absorb radar waves, and they've made so none of the angles on them reflect radar waves back to where it's coming from. So you can point a radar at them and you don't get any reflection back, so you can't see them until they've dropped a bomb on you, which is generally unpleasant, which is kind of the aim of the plane.
Like for customised VW then or something, yeah.
So you could certainly make a car out of similar materials or materials which don't reflect radar. If you could make a car mostly out of wood, for example, then that doesn't reflect radar almost at all, so you wouldn't pick it up. I guess what she means more is so you can't see it at all, so it's actually invisible. You can. There has been some work on this sort of thing. You can just about build a kind of cloaking shield around things. It only works with microwaves at the moment. You can make very, very special materials, which if you imagine the light's coming towards you, it kind of hits this big cloak. It would be huge and very thick and heavy, but then it sort of bends around you and then kind of comes back together and ends up carrying on exactly how it was before. So there's no way of knowing from the light that you were standing in the middle of this cloaking material. It does work, but they've only got it to work with microwaves so far. But they are working on shorter and shorter wavelengths. They've got to improve it by a few thousand times before you can get it to work with real light.
Obviously, be quite good then for dodging the congestion charge or something.
Indeed.
Right now, though, on the phones, here comes Dave with a question for Dr. Dave. Hello, Dave.
It's a question about research.
Uh-huh.
I was wondering if anybody was seriously researching multiple DNA configuration syndrome.
This is where you can get more different bits of the body having different bits of DNA in them.
Different configurations, yeah.
Yeah, I'm not an expert in the area, so I wouldn't know anything about the present research. I do know that it happened. I think it's often happens if you start off with two twins, and then for some reason they kind of merge together, a bit like Siamese twins, but much more... but much deeper and much earlier on in the process. So you just have two balls of cells, and if they just merge together to form one ball of cells, then the cells kind of just sort of start working. They start growing into a baby in the way they should do, and they kind of work. But if it happens early enough, they'll just continue making one baby rather than two. And so you end up with DNA from the two original sets fertilized eggs in different parts of your body. So you could end up with one leg from one of the twins, another leg from the other one of the twins.
Yeah.
So you can get people with different DNA in different parts of their body.
Yeah, there was a particular program I saw was about a woman who's nearly had a baby taken away because they were DNA tested. and the father was the father, but the
mother didn't seem to be the mother.
The mother wasn't the mother. But apparently it turned out that she had the DNA configuration of an aunt.
Yeah, I'd be surprised if it actually got cells from the aunt, but I could imagine that her ovaries had the DNA from essentially her sister, but the rest of her body had the DNA. This is basically two sisters which have merged together. So it would be as rated to her as a sister or maybe an aunt.
Isn't it possible, though, that all siblings from the same parents have identical DNA, but they're using just different bits of it?
The way when eggs or sperms are formed is that an egg has a strand of DNA and a sperm has a strand of DNA, and those two get put together to make the full set of DNA for a person. So you should have two different copies of every gene, every bit of the DNA in your DNA. When a sperm or an egg is made, your body kind of takes your own. If you're making sperm inside your body takes the two strands of DNA and mixes the two up at random, and then splits the two off and puts one in one sperm and another one in another sperm. So to get two normal brothers or sisters with identical DNA, it is theoretically possible. But there are millions and millions and millions of individual places where it could split, where it could have randomly thrown the dice and essentially picked which of the two strands it used each of the millions of times it's cut it and randomised it. The odds are so unbelievably unlikely that it never would actually happen, I think.
No, what I'm saying is that within the actual DNA of all the siblings, I believe there's something like 98% of it is supposedly duff. But I'm wondering if this is coded out so it's not used.
Yeah.
All of the siblings have exactly the same DNA, but different configurations are used, and all the other configurations are actually locked out.
You do get effects with some things, particularly women, because if you imagine men have got an X chromosome and a Y chromosome, and the Y chromosome is really quite rubbish. There's hardly anything in it. It doesn't do very much apart from make you male. But the X chromosome is enough to do all the jobs of the X chromosome in a whole person, because in men. But in women, they've got two X chromosomes. So normally you'd think that it would make twice as much of all of the proteins which one would make. And this would kind of cause all sorts of havoc. So what happens is one of the two X chromosomes turns off, and this sort of happens at random in different parts of a woman's body. And so you can get sort of some things like if one chromosome, say, gave you blue eyes and the other one gave you gave you brown eyes, it's possible that you'd have one eye which is blue, the other one brown. I'm fairly sure that gene probably isn't on the X chromosome, but it's the sort of idea.
Okay, Dave.
Thanks very much.
Thank you very much.
Cheers, sir.
Thank you.
Bye-bye.
Dave with his question, multiple DNA configuration. Dave, there's not a lot you don't know, really, is there?
There are many things I don't know.
Anyway, Peter has called in and he said, what is St Elmo's fire, apart from a song by John Parr?
This is this strange glow, very spooky glow you can get on. The people who really used to notice it was on sailing ships during electric storms, during lightning storms, and just before lightning came down, they'd find that all the rigging started to glow in a really spooky kind of way. If you're at night and the rigging starts to glow, I can imagine it'd be very worrying in the middle of a big storm. What's going on here is that if lightning's about to strike, basically you've got a huge voltage between the cloud and the ground. And so electrons are trying to flow between the ground and the cloud. And anything sharp, you tend to get that they'll start just sort of jumping off the sharp thing and flying off, trying to get up to the cloud, even before they've actually sort of started to make sort of just before a spark happens. And these electrons flying off the really sharp thing can bounce into atoms, give them energy, and then they release this energy as light and make them glow. It's called a corona discharge. I've built a machine which produces lovely corona discharges. If you look in a dark room, it spins and works up to about 20,000 volts, and you get these beautiful blue glows all over it in a dark night. But yeah, it's sort of, if one of these coronas gets very, very strong, then if you get strong enough, the electrons can move through the air and hit another air molecule and knock an electron off that second air molecule, at which point you've got two electrons moving and a positively charged air molecule going the other way, and then they can bash into other things and create more and more things to flow through, and eventually they get to a critical point whereby they'll form a spark all the way up to the cloud, at which point you get a lightning strike coming down. So St Elmo's fire is sort of like lightning, which is sort of unsuccessful lightning. And although if you're not careful, it will become successful, and then your boat is toast.
Right, here's one then. Keith says, is it true that heavy metals pass through the Earth from pole to pole, causing the Earth to spin?
I'm not quite sure where he's got this idea. Basically, the Earth is spinning fundamentally because it started off spinning 4 or 5 billion years ago. The Earth is spinning relatively fast compared to other planets nearby. We think a lot of the spin of the Earth came when a planet about the size of Mars collided with the Earth slightly off-centre, at which point the Earth span really fast. If you imagine something really heavy hitting something else, huge speed, it's going to spin very fast. And also in that impact, it threw off lots of rock and things, which then coalesced to form the Moon. And basically, there's very, very little friction on the Earth. The Earth is huge, very, very heavy. It's got lots of momentum. The only thing which is slowing down its spin is actually tides from the Moon, which do slow down the Earth's spin, which means that about 250 million years ago, there are 400 days in a year rather than 365. People have found that out by looking very carefully at corals, which put on an extra layer every day. And if and in the summer, there's more food around, so they put on bigger layers than narrow ones in the winter. And you can look at these layers and work out the 400 days in a year, 250 million years ago, as opposed to 365 now, because the tides have been slowing down the Earth's spin for that time. And if you do the calculation, how much it should slow down, it's about that calculation comes out about right.
Now then, Graham would like to know if it is true that electricity usage of computers and their servers will be more damaging than air travel by the year 2020.
The rate of use of electricity in servers in big data centres is increasing incredibly fast. If you extrapolate that growth until 2020, it will certainly be more than air travel. I think probably they'll suddenly discover that it's getting very expensive to use all this electricity, so they'll probably get more efficient. So whether they will actually become more damaging than air travel depends on various things, but it is looking like it's a very strong possibility, certainly.
If Saudi Arabian oil is too sulphurous for petrol diesel, what is it used for? That's from John.
I think it depends where you're using. There's definitely mechanisms if you get the right oil refinery of removing sulphur from petrol and diesel, so it makes a lot less smell. I don't know if you've noticed that the smell of diesel has changed in the last 10, 15 years.
No, I don't go around sniffing diesel on purpose, but yeah.
But when I was a kid, the smell of diesel was really strong and very definite, and now it's much, much less. It's because they've been scrubbing a lot more of the sulphur out. But yes, a lot of the very horrible things which are left over after you've done all this thing are often used to drive ships with. Ship bunker fuel is very sulphurous and quite unpleasant stuff.
All right, OK. Hi to Mike, who sent a text in saying, Dr. Dave, famous bouncing bomb hit the dam, sank to the bottom, then exploded. Surely inner bomb workings must have been damaged by the first impact.
Bomb workings are designed in order to be able to take an impact, and compared to a normal bomb which has been dropped from 20,000 feet, some bombs, the earthquake bombs, which Barnes Wallis, the same guy, designed bombs which you could drop from 30,000 feet into the ground, and compared to dropping them from 60 feet down, that's incredibly violent. So if you can build a bomb which can survive dropping 30,000 feet, hitting the ground faster than the speed of sound, and then still work to explode, you can certainly build a bomb which can drop from 30 to 60 feet, and then bounce on the water a few times, and then bounce off a dam and slow down. So basically it's a case of engineering. You can certainly build bomb triggers to survive that sort of thing.
That's it for this week. Our doctors will be back with me next week for more Ask the Naked Scientist. But don't forget, you can also catch them on the Naked Scientist podcast, which you can find on the Naked Scientist website, www.nakedscientist.com.
The Naked Scientists are sponsored by the Wellcome Trust, the EPSRC and UK Fast. For more information, look us up online at nakedscientists.com.